All right, welcome everybody. My name is Roan Kattouw. During the day, I work for Wikipedia, and we're awesome, and we're hiring. You should check out our booth at Union Station. But at night, I volunteer in this project to bring open source software to elections. So that's what I'm going to talk about today, and I hope this clicker works. So I should have set screen mirroring for this. I'm going to talk in 4 acts here about what an open source voting system is and why you might use one. So first, I'll talk about why you use software for elections in the first place. Then secondly, I'll talk about why open source is particularly important for this application. Thirdly, I'll talk about what kind of open source software is out there in the world to do election-related stuff. And then finally, I'll talk about the project that we're doing in San Francisco and what's going on with that. So first, I'll back up one step, which is why would you use software for elections at all? Like, aren't elections these things that you do on paper and then people count them? So in November 2016, we had an election, as you might have heard, including in San Francisco, where I live. And there is a voter guide that gets mailed to every person in San Francisco by the city. And the introduction from the Director of Elections began as follows: "Big ballots are back." And what does he mean when he says that? He means stuff like this. This is actually not from November. This is from this past June when we had a special election. These are the local ballot propositions that you could vote on, and we had ballot propositions A, B, C, D, E, F, G, and H, and I. And if you thought that was bad, that was not November. In November, we had A through X. So we had to vote for, your federal office. You're the president, U.S. Senate, U.S. House. You have state assembly, state senate, state judges. You got to vote for, county supervisor, city college board, BART board, all that kind of stuff. And then you got your propositions. We love ourselves some direct democracy in California. So we had 25 local propositions and 17 statewide ones. And if you add this all together, you could have up to 52 things to vote for on one ballot. Some people had 50, some people had 51. It sort of depends on where you live, if the various intersecting districts that you're in have an election that year or not. In total, there were 60 things being voted on across the city, because you've got, we're in 2 different House districts. They both had elections at the same time, so it's a little bit more. That meant that we had a ballot that was 4 pages double-sided. So people actually sat there and filled out. They sit in the polling place. I've seen it. It takes a long time. And they go and fill out the ballot front and back, and then 4 more times. If you were lucky, you only had 4 pages double-sided. If you were unlucky, you had a 5th page. And if you add this all up, 414,000 people voted in November of 2016. It's about 1.8 million pages of stuff, and they're not letter-sized pages. They're pretty long cards as well. So it's a lot of paper. It's a lot of data. And secondly, another complicating factor that we have in San Francisco and a few other cities in California is that we have Rankchoice voting. So for certain local offices like Board of Supervisors and Mayor, you can indicate your first, second, and third choice, and then there's an algorithm that happens for, if your first choice loses, then your vote goes to your second choice, and if that person also loses, your vote goes to your third choice. This gets complicated, and it gets more complicated when you have more votes. So for a supervisor, we have 11 districts in the city, so you really only have 30 to 40,000 votes in high turnout elections in high turnout districts, and you might get down to 10 to 20,000 in lower turnout situations. But we had a mayor's election in June that was highly contested. It had used ranked choice voting. That was 253,000 votes. So it's a lot of data to deal with, and you can do this by hand, but you're not going to do this by hand anymore. You need to run an algorithm in a computer to compute this result. The result ended up looking something like this. These were the last couple of rounds of eliminations. So in the 7th round, Angela Alioto has the fewest votes, so she got eliminated, and her votes get redistributed, and so on and so forth. The kinds of numbers involved, you're not going to have humans take 66,043 cards and then sort them into 2 piles, one that's 13,210 ballots tall and one that's 44,724 ballots tall. You're just going to put all the data in the computer, and then it will just generate this table and tell you who won. So that is a good reason that you want software. And to review, you're dealing with a lot of data. If you have 50 plus items on any given ballot and you have 400,000 people voting, That's 20 million votes, essentially, if you break it down per contest. You have to do ranked choice elimination rounds between like as many as 21 candidates, because that happened once, and as many as 250,000 votes. That's a lot of processing that you don't want to do by hand. A computer can do it in seconds. You have to input all the data in a computer somehow, which is why you want to scan your ballots and have like computerized interpretation of the votes, because you also just can't input all that data fast enough or hire enough people to do that if it's this much data. And other advantages is if you use computers for voting that the voters interact with directly, you can reduce or eliminate voter error. If I fill out my ballot and then I have to feed it into a scanner, the scanner can spit it back out at me if it notices that I voted twice for the same thing when I'm not allowed to. If I vote on a touchscreen, it can just refuse to let me enter votes that are invalid. Right? So you can vastly reduce the number of votes that get rejected completely because they're invalid for some reason, because the system will just not let you make the mistake or will warn you against it. And finally, not everyone can like read the size of the font that is printed on the ballot or like see at all. So if you have a touchscreen device where you can blow up the font, if you can attach headphones to it and like have the ballot read out to you and you can push the button to make your selection, those are really great features that help a lot more people vote. So there's good reasons to use software, but as we've all heard, software can also be dangerous. So I'll briefly go through a couple of voting systems and then linger on one and then go on to sort of the next topic of why we want to use open source software for this. So you can do hand-counted paper ballot. You could do the old-fashioned way, like the way that we used to do in the days of yore before computers. Everyone fills out a ballot on paper, and then people go and sit down and count everything by hand. Some countries still do this. They have hints. They don't have like 52 things on one piece of paper to count. But there were countries that went back to this after some of the events of 2016 or never left it at all. You can do what we do in San Francisco is people vote on paper in general, and then they go through a scanner, and the scanner decides what the ballot means. There's also these what is called direct recording voting machines, and these are things with levers. You've got this expression of like pulling the lever for this candidate, right? And it's because some of the eastern states had these machines where the voter walked up to a machine and you had like a lever for each candidate. You pulled the lever, and then inside the machine there's a counter that gets incremented for that candidate, and then at the end of the day you can sort of open the machine up and look at what the counters say. And this is all mechanical. This is not electronic. So that used to exist. And then in the early 2000s, we saw the rise of the direct record electronic voting machines, which is basically the computerized version of that. So typically, like touchscreen machines where you like enter your choice and it just says, "Thank you for voting," and there's like a counter inside the machine, like a variable, right, that counts how many votes each candidate received, and at the end of the day, you ask the machine, "What's the result?" and it gives you numbers. So it is hopefully obvious that that if you do this without a terrible paper trail, it is a terrible, terrible idea, and you should not do it. It's super unsafe and unauditable. Even if the software was somehow like open source, which it's not, let's be honest, there is no way to audit the results. And this is an issue with like the lever machines, right? You can't go back and like look at every vote because the votes never existed on paper. With these systems, you can check if you added up the results from all the precincts correctly, but you can't check if you can't double check if people actually voted the way they did, because all you have is what the computer tells you. So 14 states still use this somewhere. There are 5 states that use these machines statewide. Georgia is actually getting sued over this, where a group is demanding paper ballots, and the judge seems to basically agree with them, except also believe that it's too late now to switch for November, but they're hopefully going to be forced to switch to paper ballots soon for the next election. And in many European countries, this was tried in the early 2000s as well, and then it ended up being banned, either legislatively or through court cases. Someone actually sued over this in Germany, and the whole concept of electronic voting was just found unconstitutional. So we're far ways from that, but that is a side note. This is super insecure. If you live in one of these states, contact your representatives and tell them to fix the situation. Let's see. Is this working? Yeah. So to use software safely, you want to use paper ballots. You want to audit everything because open source or not, you can't trust that the software interpreted everything correctly, but that's why you have the paper. So in California, for example, we have a requirement that 1% of all the polling places get their ballots audited. So you open up the boxes, you hand count all of the ballots for the polling place, which is only a couple hundred, so it doesn't take that much time. And you compare it to the machine results. And then if that matches, you trust that it also went okay elsewhere. There's an emerging technology called risk limiting audits that I will get into later, where you use statistical methods to determine whether things went right. And another great thing that you can do that we are doing some of is publishing data. So in San Francisco, for example, with our Rankchoice voting system, we publish a database that is essentially like a row for every vote that was cast with the first, second, and third choice for that person made. And then any member of the public can download the database, write their own code to do the Rankchoice voting algorithm, and verify that the results was correct, that the city did the redistributions of votes correctly. And what we're hoping will happen in the future, and what's sort of emerging as well, is the idea of publishing images of every ballot that was scanned. Some of the newer scanners have technology to do that. And then you can write your own, optical recognition software to recognize what each ballot is and see if you get the same result as the government did. So that's sort of where that field is headed. So in San Francisco, we use a system that is not open source, surprise, surprise. We use a proprietary system by a company called Dominion, which was since acquired by Sequoia, because there's a lot of consolidation happening in that market. People mark ballots by hand. They then feed them into a scanner, and they're scanned immediately when they cast them. We do have direct recording electronic machines for accessible voting, so the people that need to wear a headset and have their ballot sort of listen to the ballot and push a button when their choice comes up. That uses direct recording machine, but that has a paper trail, and because of weird technicalities for how this was certified, we're actually required to then transcribe this paper trail onto ballots and feed it into the scanners, which is stupid, but that's how this works, and it's a lot safer. And a lot of our people vote by mail, so those ballots get scanned as well at a central location. And so this is what that looks like. I think this image got rotated wrong or something. It's very blurry in any case, but this is the hands of a person feeding a ballot into a scanner, and this is sort of, the scanner reads the ballot and then it puts it into a box, and the box gets emptied at the end of the day. All right, so the kinds of things that you need to build a system like this, right? Because we want to build this, we just want to build it with open source software. Is you need an accessible device, and that's the hardest part. You need a thing and software with headphones and a big push button and magnification and all that kind of stuff. You need a ballot scanner that you put at your polling places that voters will feed ballots into, and you need a central ballot scanner for your vote by mail ballots where you can just put stacks of ballots in and they'll just go through them at high volume. I think the scanners that we currently have are 240 ballots per minute or something, so 4 per second. It's really impressive to watch them just fly through. So that's the kind of hardware that you need to work with. And then the software components that you need software to lay out ballots, sort of desktop publishing kind of stuff. But you need that not only because you need to design the ballots and send them to a printer, but also because when the ballots come back into the scanner, you need to know what's where. If a voter marked a circle, or in San Francisco they connect arrows somewhere on the page, you need to know what that location on the page means. Which contest is that? Which candidate is that? You need software to obviously scan the ballots and interpret them, which depends on that. You need something called ballot adjudication, which is where if the computer can't make a confident interpretation, can't make a decision on how to interpret the ballot, you need a workflow to take that image and surface it to a human who is asked to interpret it. And this shouldn't happen very often, but for the cases where your computer doesn't know what to do, you should be able to do that. You should be able to take that image and say, help, I don't know what to do, decide this for me. You need software to do what's called tabulation, which is really just adding everything up, which is extremely easy except when you have the Rankchoice situation that I explained earlier, where you actually have to write an algorithm with a bunch of edge cases and be very careful. And you want to do results reporting, like the table that I just showed you with the different redistributions, the various formats that we publish election results on the website. There's a letter that the director of elections needs to sign to officially certify the election. You want to be able to generate all those things and for public consumption. And then finally, you want to have some software features to assist you in audits, and that's something that I'll talk about in a minute. So going towards more like why we would want to use open source software, proprietary software has all the classical problems that you might have heard of. It is expensive. In San Francisco, we spent $10 million to buy the system, including the hardware, and then we spend, on average, about $1 million a year to license it. And some of these are ongoing license costs, some of these are per election costs. So this is an expensive year because we had 2 elections in 2018. The source code is secret. We don't know the code that runs our election process, and the city government doesn't even know that because it's proprietary to the vendor, and they're not telling anybody. If you want to change your voting system for some reason, you're screwed, because you can't, unless you can convince your vendor, which is like one of 3 players in the market, to implement your thing, which will either take vast sums of money or it will not be available. The fact that we use Rankchoice voting greatly limits our procurement too, because not all voting system vendors even support that. So that leads you to vendor lock-in. It's really hard to switch vendors because you have to get like new equipment and new everything. Often have to get a new ballot design, which means that the public just notice that you switch voting systems, which ideally they shouldn't. If any of y'all have paid attention to the coverage of this year's DEF CON or last year's DEF CON or the year before, you will have seen headlines like, 11-year-old cracks voting system, or like, all these voting machines that they bought on eBay and then like hacked within 30 minutes, right? There's lots of insecure software running on these things, and lots of ways that they are compromised, and the vendors don't care that much. But we do. So let's see, trying to go to the next slide here. Here we go. So open source is somewhat uniquely important here because election software is critical infrastructure for the functioning of our society. Elections are a critical process. And without trust in election integrity, we don't really have the society that we want to have. So a lot of places in the United States have antiquated voting technology that they can't afford to replace. And part of that is because of the history behind it is when we had all the hanging chads scandals in Florida in 2000, the government was like, we must solve this problem. So they gave states a ton of money in 2002 under the Help America Vote Act to get these fancy new machines and get these touchscreen devices so that we would never have an ambiguous ballot ever again. And then the money stopped coming. So now everyone's got their machines from 2002 and they're getting old and they need to be replaced, and now there's no money for them until, unless and until the federal government comes up with another infusion of cash, which good luck getting that from this government. Everyone's going to be stuck with old machines and they're not going to have the money to buy new ones. So it's also important to have high quality software and hardware, and it's important to reduce the cost. So the practical advantages that you have here of using open source for this is that over time and across jurisdictions, it ends up being cheaper, because the business model of these vendors is, one, the fact that it's a small market, but also the fact that they can sell the same product to multiple people for the same price, because they're not allowed to share. So they sold the same thing that they're selling to us for $10 million and then $1 million a year. They're also selling to neighboring San Mateo County for $10 million and $1 million a year, or whatever they're paying, because we might not know that. So if you develop an open source system that everyone then shares, the authority that develops it bears a lot of the costs, and that will, honestly, that will probably cost you more than $10 million. But then you have it, and then it's much cheaper to redeploy somewhere else. Not everyone keeps paying for the same thing over and over, and there's no one making a profit except the people that originally built it. So, and on top of that, if you want to innovate or change things, like if you're a jurisdiction that wants to try some new sort of voting system, like maybe you want to do like multi-member ranked choice voting, which like virtually no one in the US is doing right now, you're not at the mercy of one of these 3 big companies to implement it for you. You can do it yourself, or you can hire people to do it yourself. They need not be the same people that developed the original system. You have a lot more flexibility, a lot more space for innovation, and ends up being cheaper overall. It's also a great reason why we need state or federal funding for this, because you have a tragedy of the commons problem. It doesn't necessarily make sense for one county like San Francisco to develop a system like this if we're going to bear all the costs and end up basically putting more money into it than we get value out of it, but then everyone else gets value out of it. So That's a great argument for sharing the cost. That's why we should get state funding for this, which we've tried to do. It would be great to get federal funding, but that's not going to happen until 2020 at least. So moving on, I'll briefly touch on some of the other open source software efforts that have gone on in this space. So there is a project called Prime3, which was written by some professor in Florida at a university and picked up by the state of New Hampshire. So this is a GPL project that you can find on GitHub, or at least Prime3 is. One for All is a name that New Hampshire branded their thing with, and they took it and they added some things. And this is an accessible voting system. So you can buy some hardware like off the shelf. You can just like go on Amazon and buy like a tablet and a printer and a keyboard and headphones, and hook it all up together, put the software on a tablet, and then you have a device that people with disabilities can use to vote. But what this does is it ends up printing a ballot, so it doesn't actually do any of the vote counting or any of the sort of the critical path parts of the voting process. All this lets you do, which is important but not everything that you need to do, is let a blind person come in and use an audio interface to print a ballot. And there's also cool sort of non-disabled person features, like you can have an app that you make your selections on ahead of time, and then it generates a QR code on your phone. You scan the QR codes in the machine, and then your ballot comes out of the printer. So these are some cool applications that they're playing with up in New Hampshire. And this is what it looks like. This is a still from one of their trading videos from New Hampshire's Office of the Secretary of State. And that's like, it's a tablet, a keyboard with big print letters, and then the gray box behind the lady's arm is a printer, and what she's holding in her hand is headphones. You just buy this equipment, like at Best Buy or on Amazon or whatever. You put the software on it, and you have your accessible voting set up, is the idea. Another really cool software package that's been developed recently is something called Colorado RLA. So I talked earlier about audits and how in California we have this simplistic approach of you randomly select 1% of all the polling places, you audit them. But a professor at UC Berkeley developed a more advanced method for doing this with statistical methods that's called risk limiting audits. And this software was built to facilitate that. So a company called Free and Fair, which builds open source election software, developed this, was commissioned by Colorado to develop this last year. It's released under AGPL. And the first phase has been used in an election in Colorado already, and the second phase is in the works. And so this is a statistical method that you can use to verify whether your scanners are counting things correctly. And arguably, this is the most important step of it, right? Like, it doesn't really matter what you do to obtain the result as long as you can prove that the result is right. So the way this works, real quick, is that you get your software to interpret your ballots. You assign an ID to every ballot, and you link the software's interpretation of the ballot to the ballot ID. And then you just have like a giant database of like, this ballot ID is a vote for this person. Then you randomly select a couple, like 100 or so ballot IDs, and you tell the people to go find those ballots, which might mean that they have to call someone up in a remote corner of Colorado, which is why you need software to coordinate and all this stuff. But you say, find the ballot with this number. They find it, a human looks at it and says, I think this is a vote for candidate X. And then you look at your database to see if it's actually a vote for candidate X. If this matches enough times, then pretty quickly, by only examining like a couple hundred or maybe a couple thousand ballots, depending on how close the election was, you can get to the point where you have 95% or 99% certainty that you call the correct winner. Because especially if the margin was really big, the errors have nowhere to hide, right? You need to be finding errors, otherwise it's statistically extremely unlikely that your result is wrong. So this software facilitates that and helps them with a lot of the logistics of like tracking all these ballots and like tracking down which county owns the ballot with that number and so forth. Other projects that have happened and sort of failed, for various definitions of failed. One is in Travis County in Texas, which is where Austin is, had a project called StarVote, which was a design for a full voting system and an election management system and everything that you would want to run an election. They were somewhat waffly on whether they weren't going to release it as open source, but they said they intended to. And they abandoned it last year because they couldn't get someone to bid on the entire project. And they said that no combination of bids that they got would have satisfied everything. And I think that there are some mistakes that they made with the way that they procured it, and they sort of designed their thing up front. So that failed. And Los Angeles County has this project called VSAP, which is a full, they use it called voter-centered redesign of like everything, the software and the hardware and the process and all of it. And they commissioned that for $282 million, which is a lot of money. And the system has now been certified. It will count mail votes in November 2018 in the upcoming election. And in 2020, they're switching to a semi-all vote by mail system, so then it will count all ballots. This has been advertised as open source, and in fact, the press release, when it was certified last month, said like, first open source system certified. So we did a public records request for the source code, and they denied it. There's some stuff in the contract is open, we found that, and there's some stuff in there that LA County reserves a right to publish it open source if they want to, but it sounds like the best that we could possibly hope for is quote unquote disclosed source, where we will be able to see it but not reuse it. So it's trying to use this open source language from time to time, but it's not really. So the San Francisco project is the only one ongoing that hasn't been abandoned that would develop a system that is actually open source and can be reused by other jurisdictions. So our goals are to have the project be open source from the start. Like, we think it should be GPL v3, but whatever it is, like the first thing in the repository should be a license file that explains what the license is. It should be developed in the open. It should work the way that open source projects actually work in the real world, not like we're going to develop this and then maybe we're going to make it open source later, but no promises. We want a commitment up front for that. We want it to use off-the-shelf hardware as much as possible, so stuff that you can buy on Amazon or at Best Buy. We want the documentation to be openly licensed, and we want, as I said before, we want it to be cheap and easy to reuse. Our neighboring counties and other places, at least in California, if not elsewhere in the nation, should be able to just pick this up, buy their own hardware, and run with it. That should be easy and that should be cheap. And we're hoping to be able to set a model for California and for the US. And we hope that because we're San Francisco, where we have no shortage of tech companies and tech talent, that this should be possible, right? And that if anyone can do it, hopefully it's us. So we're hoping to make that happen. So there's a long history of advocacy there, where in 2005 people started talking about this when some of the first scandals came up about electronic voting machines that had been rolled out about 3 years prior. And then there's this whole history of bureaucracy where it takes about 7 years to go from like establishing a task force to like getting the Elections Commission to agree that this is something that we should do. But from there it's starting to move a little bit. We got a little bit of money to do a planning phase, and last year a technical advisory committee was formed, which I sit on. That's why I'm here. That's how I fit into this. Where we got some tech people from around the Bay Area together to advise the city government on how they should go about this project, because the people that run elections in San Francisco are people who know about elections, not necessarily people who know about software. So in 2018, we didn't get as much money budgeted for this as we wanted. We had hoped for $4 million, but we got $1.7 million over 2 years allocated to development of this project. So that's really exciting. And so the next steps on that are actually that the city's going to hire a project manager, but more about that in a bit. This project has been supported by a lot of organizations, and this is a very hilarious slide to me because it's like 1/3 of it is tech companies that people in this room recognize, like GitHub and like organizations like the Open Source Initiative, and then there's like the San Francisco Democratic Party and like the Harvey Milk LGBT Democratic Club, and then there's other advocacy organizations like the National Election Defense Coalition, which like most people only know that like 1/3 of these people exist, and they're a different third for every person. So we've got like an eclectic coalition of people behind this. And we've got some nice press coverage about it, but it's kind of an out-of-date slide because I'm trying to find the date on this. This is November 26, 2015, so I should update this slide. It's kind of an old headline. But more recently, this summer, the Civil Grand Jury released a report about open source voting in San Francisco, where they made some good recommendations on how we can move this forward. So there's some attention coming to this, and as I said, there's now some dollars behind it as well, which is exciting. So the first iteration that we're proposing here, because you should develop this iteratively, that's how things work in the real open source software world, is start with vote by mail ballots. San Franciscans love to vote by mail. In the November 2016 election, 63% of our votes were cast by mail. And in this past June, it was almost 65%. And I think that's just going to keep going up, and we'll hit 2/3 before 2020. So if you're able to do vote by mail ballots only, you're actually covering like the vast majority of ballots already. It is the predominant use case. So to do that, you need surprisingly little. You need hardware and software for a scanner, and in particular, you need hardware for a high volume scanner. You need software for layout encoding and tabulation and results reporting, and some auditing and batch management stuff that's boring that I'm not going to talk about. But you need basically the basics to make sure that you can interpret and count votes. But the appeal of this is that you only need to roll this out on about 4 to 6 devices instead of like 600 devices, because you're not doing polling places. And your 4 to 6 devices are going to be in the basement of City Hall, operated by a select group of trained people, rather than like be located in random parking garages where they're going to be operated by everyday people and just literally random voters who walk in. So it's a lot easier to get this kind of stuff right, where you can train the people. You only need to buy a couple of devices. You don't need to have like hundreds of devices that you need to truck around the city and need to be completely foolproof. So this is going to be easier to phase in than just like polling place scanners. Is especially going to be easier than accessible devices, because accessibility is hard. People have all sorts of issues, disability issues that you've never imagined, and it's really hard to get that kind of stuff right. And in addition to that, we want to do modular procurement as well. We want to be able to like put out different parts of the system to different vendors and integrate it together later. We want to be able to switch vendors halfway through if we're not happy. So by building the system in pieces, you're also doing that. And with this, you can sort of prove that the system works by spending like 10% of your money on 64% of your use case. So that's a great trade-off, we think. So currently, we have our technical advisory committee. We have our monthly meetings and we develop recommendations, but our recommendations document is actually on GitHub because we practice what we preach. We eat our own dog food, etc. So you too can submit a pull request to our recommendations document if you think something should be in there, and we welcome that. There was a feasibility study that was commissioned last year that came back early this year with a super flawed report that we've shot full of holes that had outrageous cost estimates, which we're now trying to disprove by making some proofs of concept ourselves. Convincing government people to actually spend money is hard, especially if they see scary numbers. But we got $1.7 million in the city budget, as I said, for the 2018-2020 budget. So we've got something to move forward with, and the city is now recruiting to hire a project manager for this project. And hopefully that's one of you. There was also some proposals for getting state matching funds from the state of California for this project, but that unfortunately had died. But nevertheless, the city has put some of its own money to that, so that's been good. And you too can help us make this a reality. You can support us by signing up as a supporter, which I will have sheets for, where you can put down your email address and get our newsletter and everything. You can follow S of Open Voting on Twitter for updates, and also because having more followers makes us look good, because that's the way things work. You can contribute by submitting pull requests to our recommendations at osvtac.github.io. And you can apply to be the project manager working for the city of San Francisco to help make this project a reality. Or if you don't want to do that, you can encourage your friends to do so. So at bit.ly/votingjob, we have that job description up. And I hope that we can get someone good in that position, because that'll be really important. And finally, if you're not in San Francisco, you can advocate for this locally. You can build support in your county or in your state, talk to your elected officials and your election administrators, and try to get them to see that this is important, and that collaborating on software that we can all use that is not owned by companies to run our elections is important. So that's all I got. My contact is at the top of the slide if you want to get in touch with me about this. And then, as I said, apply for the project manager job, spread the word about it, follow us on Twitter, and our recommendation document is on that URL, and more information is there as well. And you too can submit pull requests to it. So thank you very much for listening, and I hope you found this exciting.